Okay, so here's our new unit. Before we get started, I'm guessing you've heard this term before. I'm just guessing. But when I write that up there without trying to get smart computer sciencey on me, where have you heard this before? What does it mean? Where have you heard it? Math? Anywhere else? I know you've heard it in more than just math. Science, yeah. And you guys are just studying science at this point, right? It's not physics, chemistry. Those are kind of units. But next year when you pick your sciences, you're probably going to hear that term before. Even outside of math and science, right? Don't we just use that in common speech? Give me an example of a sentence that uses it that's not a math or a science question sentence. Somebody, where you'd use that word, variable.
Where you're just deciding on something?
Yeah. Like, hey, the weather this week sure has varied. It's quite a variable to describe. I mean, variable is maybe a little bit, but that would be the root of that word, right? The root of variable would be to vary, which would just mean choices, right? Lots of things to choose from, okay? Another way to describe something that varies is something that changes, okay? Okay, now let's get a little more technical. Give me an example of a variable in math. Okay, but give it to me in math. Like I'm your math teacher right now. Just tell me, show me an example of a variable. So like a letter. What's the most common letter in math? Okay, so keep going. X what? X equals 2. How about that? Yeah? How about X equals Y? I heard that one. Excellent. Okay, that's very mathy. Now let's just jump to science. Science, X is also used, but let's say you're in science and you're trying to calculate, you're like doing a physics equation, and you're trying to figure out time. What would the variable be? T. Well, that's interesting. In science, it would be T. Whereas in math, it's X. What's X? In math. Go ahead, tell me, what's X? It just is X, right? And you know what? I don't know what math you guys are taking, but as a math teacher, I often have that conversation with students when they say to me, why do I have to worry about X? It's so stupid. I'm never going to do this again in my whole life, right? And you know what? In some ways, I can't argue with that, okay? Now, in science, they'll go a little bit smarter. It's like T for time. Now, I'm not saying they don't use X. They might very well do that, but it represents something, right? So this represents something. In science, it's easier. You can say, oh, T represents time. In math, you'd be like, well, X represents, oh, I don't know. Give me an actual scenario where it fits. Oh, X represents the number of days of the week in some sort of word problem. Okay, now I get it. Now it actually represents something. So let's put this stuff together. A variable is something that represents something, and it changes. We're done. You guys are good. We're done the unit, because that's what a variable essentially is. Correct, in the sense that that's what it is, but I did make a fancy PowerPoint for that, so let's try that. Oops. All right, everybody monitor off, spin your chairs to the front here. We will be doing an actual demo, but I want to make sure you guys are paying attention to this. All right. Plus, I put up a picture of a hot dog to make you guys hungry. Nope. No, it's not. All right. Okay. So, obviously, people like scientists examine relationships in the world and often express those relationships in things like formulas, like, for example, Einstein's famous formula, E equals mc squared. I've even seen some of the students wear that as a t-shirt. Woo, super cool. But that's a famous form, perhaps the most famous formula in the world. Okay? And the thing is, we knew that the E, the M, and the C were essentially variables in that formula. They represent mass and energy, things like that. And they are symbolic. They represent something. So they're variable objects or just variables. The variable object essentially describes the fact that they change. They vary. Okay? So computer science uses variables as well. But computer science, as you know, isn't just a theoretical subject. It is a very practical subject as well. So in computer science, the way I would define a variable is it's a piece of memory that we give a name to, and it holds a value. It remembers something. So for example, this is all the memory in your computer's Like, so your computer's full of memory, right? So if we make a variable, we just take a piece of that. We go, okay, that's my piece, and I'm going to use it for my program. So you're reserving a piece of memory, like reserving a table at a nice restaurant. You're saying, that's my memory, don't touch it, I'm going to be using it. In order to do that, in order to reserve that memory, you have to give it a name so that it knows what to call it, right? So like, table for Mr. Walks, right? It's reserved for that person. So you give it a name, Mr. Walks' money, okay? Then, obviously, you want to use this piece of memory, so you put stuff in there to remember. So into that piece of memory, I put all my money. There we go, okay? Now, it also can remember that, because that's what memory is, right? It remembers that value for you. But as well, you can use that, just like in math and science, you can use that variable, or that piece of memory, to do math, to do equations, to do lots of stuff, okay? And because it's a variable, it changes, it varies. Okay, another analogy. What if you think of variables as mailboxes? Everybody has a mailbox inside their house, but this is a special mailbox. It's so small, it can only hold one thing at a time. So every time you get a letter, if there's already a letter in the mailbox, you have to throw out that letter to put the new letter in, okay? So this is a variable or a mailbox that can only hold one thing at a time. And this makes sense if you think about it in math. X can't equal both 2 and 3 at the same time. It's going to be either 2 or 3. It can't be both, right? So it can only hold one thing. So here's the animation for you guys. You ready? Here's the mailbox. I know I should be teaching art this semester as well. No, it's a mailbox. In goes the money. If I want to change it, in goes the new money, right? One thing at a time. Okay. So, okay, how do I do this? Well, in computer science, it's done through code. So you're going to write code to create the variables. And the way you write code is specific, just like anything in code. It has a specific format. So to create a variable in code, you need to do the two things. One, you need to give it a name. We had to do that in math and science as well. But here's where it gets different. In computer science, we also have to give it a type. Because in math and science, when you make a variable, what's going to go in there? Numbers, right? But in computer science, life goes beyond numbers. It could be letters. What if I said the variable is going to hold your name? Well, there's no numbers there. That's words, right? Whether it's going to hold the answer to the question, do you want to quit this program, yes or no? It might just be holding one letter, a Y or an N. It could be holding numbers, but it could be holding other things. And so that's why in computer science we're a little more specific, and we have to give it a type. Okay? So before I move to the next slide, I just want to sort of drop to that for a second and say, okay, so we got the math thing. So yeah, it's a variable, represents, it changes. So now we know we have to give it a name. And we do that in math too. We'd say X, or in science we'd say T. But remember how in math versus science, in science it was getting a little more specific, right? T is a little more specific than X. So this is math, this is science, and now even more specific is computer science. That's an M. Hi. Go ahead. Yeah, just go ahead. So the amount of specificness goes up. So now it's not just a name, but it's also a type. Because with math, we just assume it's a number. And with science, we assume it's a number. But now we got to be more specific and say, oh, it's this type of thing. But as well, something else is going to change. The way we name it is also going to get a little more specific. So let's say we're using it to store time in all three disciplines. So in math, we're making a formula to store time. We'd use X. In science, if we're using a variable to store time, we'd use T. In computer science, if we're using a variable to store time, you know what we're going to call it? Time. We're going to call it T-I-M-E. Why? Because we're typing. It's code. Why not call it what it is? Let's be more specific about it. Let's call it what it is. So it's more specific than math and science in that way. And we'll see that in the example today. Okay? Now, let's talk about type. It refers to what kind of data it's storing. We're going to look at that in a second, all the different types that C# can store. But know this. this is important. When you create a variable, it can only hold one type of data. If you need it to hold a different type of data, you got to make a different variable. So if you're going to make a variable that holds numbers, that's it. Can't hold letters. And if you make a variable that holds letters, that's it. It can't hold numbers. In the example, we'll learn that you can sort of translate between the two, but you have to make specific variables for the specific types. This, again, is where you move beyond the sort of theoretical world of math, where you just assume everything's X and everything just works wonderfully. But computer science is practical. It actually has a computer that you're dealing with, so you've got to be more specific. You can't use that sort of loose terminology you use in math and science. You got to be more specific. Okay, so what are the types? Well, in C#, there is probably about 12 types, but you don't need to know all 12 to do this course. Generally, you don't need to know all 12 at all, unless you're like some really specific programmer working some tiny little basement somewhere in some corner of the world. These are called the primitive data types. Sometimes called the built-in data types, sometimes called the atomic data types. They're the ones that come packaged with C#. Okay? So they are basic, simple forms of data. Okay? Obviously, they can get more advanced, including ones that you can create, but that's beyond the course. That's more of my grade 11 course. But let's take a look at what these primitive data types are. So the first type is called the integer. Very simple data type. You've probably heard it in math class before. The integer is a simple number that ranges from 2,147,483,647 positive numbers all the way down to 0, and then it also has negative numbers. Question. Think it out. Why is there one more on the negative side than the positive side? Think about your answer. Be specific in your answer. Yes? That's actually the right answer. Very good. Let's give them one-handed round, not two, just one. Come on, make it sound with it, right? Or we'll go beatnik. Give him a snap round. Yeah, he's right. And this is, again, a difference in math. In math, if you ask a math teacher what is 0, is it positive or negative? You know what their answer usually is? It's neither, or it's both. It has no sign, they'll tell you. It has no sign. You tell that to a computer, you go, well, what sign should this 0 be? You go, well, neither. It should be, it's theoretical. Computer goes, no, I need to know. And so they've made 0 positive. As a result, it takes up one more space, which means we get one more space on the negative side. That's why. Okay? Now, other thing that's important about the integer, it cannot store decimals at all. Don't even try. It won't let you. It's always a whole number. Okay? A lot of programs you write are always going to do that. They're just going to have whole number values. You don't care about decimals or fractions or anything like that. Just whole number values. But it's tricky when you think about things like calculations. Okay? When you calculate, something weird sometimes happens. It's what's called a truncation. Now, that's a fancy word. You sound all smart when you say it. It's a computer science word. So let me show you what I mean by truncate. Truncate essentially just means cut off. Okay? Now, this would be the case. If I said to you, what's 5 divided by 2, your answer to me would probably be 2.5. I'd say, well, I don't know what a half is. Why? Because I'm integer. I don't understand halves. You say, well, it's 2.5. And again, I'd say, I don't understand. I don't understand 2.5 because all I understand is whole numbers. Now, what then you might think is based on your math training is, okay, well, I guess I'll give them the answer 3. Why 3? Because if you round off 2.5, you're going to get 3, right? 2.5 rounded off is 3. Computer doesn't do round off unless you ask it to. By default, the computer will do what's called a truncation, which means it takes the decimal, cuts it off, and throws it away. It doesn't need it anymore. The decimal is useless to it. It doesn't assume it's going to round it off for you. It never will. And that's important to think about. So what's 10 divided by 2? 5, right? What's 7 divided by 2? Think. 3, right. It's 3. If it was 2.9999999, it'd still be 2. It throws the decimal away. Okay. Okay, so I got it. I can do integer. But sometimes I need a bigger number than that. That's a pretty big number, 2 billion. But what if I was writing a program for McDonald's and keeping track of their customers? Might go over that, right? It might go over 2 billion. So do they provide something larger than that? Sure they do. It's called the long data type, which essentially just means long integer. This is its range. I'm not going to read that number to you. Let me guess. This would be millions, and then billions, and then. Wow, you guys are good. At some points, usually people say gazillion or something like that, some word that's all made up and stuff. That's what I do, right? Right? Or they say googolplex. You guys know that word? A googolplex is an extremely large number, which is where the word Google came from, right? It's an extremely large number. Okay. So why not just always use this one? If it's bigger, shouldn't I just always use that? Well, no. Okay? Because now we have to think of efficiency. When a computer builds a variable, it takes a chunk of memory. When it takes a long, it takes more memory to work with it. And here's how it works. Every time it stores a number, and this is a little bit on the technical side, it stores it as a 1 or a 0. Essentially, that's called a bit. Do you know why it's called a bit, by the way? Anyone? In the realm of useless trivia, I can actually tell you why. Okay? So the word bit is actually 2 words put together. The B stands for the fact that this value is going to be either a 0 or a 1. Does anyone know a word that describes zeros and 1 that starts with a B? Binary. You got it. Binary is where the B comes from. The it comes from a word that you probably used in math to describe when you first learned multiplication, sort of the columns. It starts with a D and ends in IT. Digit. That's right. Bit is just short for binary digit. They just went binary digit. They just sort of pulled it apart. Okay, so that's how it works. To store a number like 37, it turns it into ones and zeros. I'm not going to tell you how it does that, but it does that. Obviously, it needs more than just one, like it needs a lot of those together. Okay, a lot of ones and a lot of zeros. So the way the computer organizes it is it goes in groups of 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 of those zeros and ones together, does anyone know what it's called? It's called a byte, B-Y-T-E. 8 bits is a byte, okay? Okay, so a byte equals 8 bits, okay? 1,024 of those bytes is called a kilobyte. And we can go up from there. Then there's megabyte, gigabyte, terabyte. Anyone know the next one? Ah, very good, yes. Why is it 1,024? Anyone? Like, why shouldn't it 1,000? 1,000 miles or 1,000 meters is a kilometer, right? We're supposed to be doing the metric system. If we're going kilo, what is this crazy 1,024? Do you know why? Because I can't help you right now. I'm right in the middle of this. You know what? Try next door. Their printer maybe is working better. So 1,024 is because you guys would think it'd be 1,000 because your math that you're used to uses digits 0, 1, 2, all the way up to 9. That's the math you use. You use those 10 digits to make numbers, right? You put them in different orders, like 47 is the 4 and then the 7, 632. But it's always those 10 digits that you use, which is the math you do is called base 10. Computer doesn't do that. How many digits does it use? 2. And 2 to the power of 10 is this, okay? So it's based on a different digit system. And this is weird, wacky trivia. Okay, speaking of wacky trivia, I think you guys, if you explore your brains, you can know the answer to this trivia question. 8 bits is a byte. 1,024 bytes is a kilobyte. There's a name for 4 bits. It's very rarely used, and it's horrible. And it's an example of why computer scientists should never be allowed to name anything, because they think they're funny, but they're not. They think they have these bad jokes of the week, but they're really stupid jokes of the week. So what's the name of 4 bits? Close. It's a nibble. You're right. It's actually called a nibble. And it's the first example of why computer scientists should never be allowed to name anything. Okay. Okay. Yeah, I know, it's painful. So there it is. Each bit represents a 1 or a 0. By the way, the first one usually represents the sign, whether it's positive or negative, so it's usually called the sign bit. Again, technical stuff. You don't need to know any of this for this unit. It's just more useless trivia. Okay. So longs use 32. That's more. And that's bad, right? Only you can reserve memory, right? So memory is a finite thing on a computer. We have a lot of it, but eventually it's going to run out. In the world of math and science, it never runs out because it's all theoretical. But in the computer, it's actually practical, and memory will eventually run out. So you have these 2 data types, the integer and the long. Both of them can store numbers. Neither one of them can store decimals. One is bigger than the other. Good news for this whole course, just use the integer. You will never have to use the long. Unless you make some program that goes over 2 billion in some way, you'll never need it. But what if I want decimals? That's going to probably happen. So now we have to switch to a different type called the float. The float is essentially more like a real number, because now it can store decimals. So here I'm going to represent it with scientific notation, right? That's the scientific thing. So it can go from a small to a big in both negative and positive, right? I'm not going to explain the whole scientific. It's just a number, right? It's a number with decimal places. That's the floating decimal type. So that one, if you do math, it will give you the decimal answer. It will give you fractions, okay? But they're bigger. They use up more memory. But you're going to need that if that's the calculation you're going to do. But then there's times you might need even more memory. You want that decimal number to be as precise as possible. Does anyone know an example of a decimal number that is like ginormous? Yeah, that's a great example. So for that one, you want to switch to the one called the double. Okay? That's what it's called. It just stands for double precision floating point number. Who cares, right? It's just a big number. And you know what? That's the one I want you guys to use, because it's the most accurate. Since you're using up memory anyways, if you're ever going to need decimals, don't worry about the float. Go with the double. Okay? So in a minute, I'm going to show you things other than numbers. But right now, I'm simplifying this process down. That if you want to make a variable, and you know it's going to store a number, okay, you got 2 choices. That's it. You don't have a million. You have the integer or the double. How do you decide? Well, does it need decimals? If it needs decimals, you go with double. If it doesn't need decimals, you go with integer. That's it. That's the only choice you'll need for the whole course. Okay? There is more specifics than even the ones I've shown you. Yes, there's the long integer or the long. Yes, there's the float, which is like the double but smaller. But I'm not going to have you guys worry about that. That's your only choice you need to worry about in terms of variables and numbers for this whole course. Okay. Moving on. Doubles use up 8 bytes. And as I said, the byte is 8 bits. So we just talked about that. So by the way, doubles use 64 bits. How many bytes? No. 64 bits, how many bytes? How many times does 8 go into 64? Ah, there you go. So, okay, just doing a little mental math, keep you sharp. All right. Now, the world is more than numbers, so we need to store, like I said, letters, characters, stuff like that. For that, there's a thing called the string. The string is a string of characters. That's what it represents. And it's a string of what are called alphanumeric characters. So strings can hold essentially anything, but it doesn't hold a value. It holds characters. So it can be alphabet characters, like A, B, capital, lowercase, doesn't matter. But it can actually hold numbers. But it doesn't hold the value of those numbers, right? So it can hold the number 1, 2, 3. It's holding the character 1, the character 2, and the character 3, not the value 123. If you wanted it to hold a value, you should have went to integer. So strings can also hold like exclamation, punctuation, and even spaces can be stored as string values. Strings have a limit. It's big, so you're never going to run into it, but it's a big limit. And it uses up as much memory as you give it. So if you're holding one character, it just uses 16 bits. If it's 2 characters, it's double that, etc. So it will eat up as much memory as it needs. So strings are a little more, they can kind of take care of themselves better. Okay. Now, on the technical side, the way it actually does this is it actually, you don't have to worry about this, but it converts those characters into numbers. Because to the computer, everything is numbers, and then everything is ones and zeros, the only numbers. And the way it does that is something called the ASCII code. Has anyone ever seen that before, ASCII? ASCII is actually an acronym. We're going to feel a little less patriotic, but it stands for American Symbolic Code for Information Interchange. So it was designed by the Americans, and it's basically a code that says, hey, you want to store the capital letter A? This is what the number you should store. It's like a lookup chart that it uses. This is it. There's actually a poster of it on the back corner there as well. So if you're looking for capital G, it stores it as number 71. And then it converts that into ones and zeros. Okay? So to the computer, everything is numbers. We just don't want to program that way. So we want to be able to still work kind of in a middle ground between the real world and the computer world. Okay. So here's some examples of strings, right? The capital letter A, the word Fred, the characters 5984, not the number, some punctuation, a whole sentence, happy birthday with spaces and like line breaks in it. A space is a character. And then this is the weird one. If I said to you, make the number x is a variable, it holds a number, nothing, what would you do? In math, you'd write x equals 0, right? But when it's a string, you think, well, how do I clear out a string so it's back to starting? You just put empty quotes, which is essentially known as an empty string, sometimes called a null string. Okay? Okay, almost there. We're almost going to code. How do we do this? Okay? So the code we write to do this, I'm going to show you right now. You give it the name and you give it the type, but actually in the reverse order. You put the type first and then the name. When you name it, it has some rules. Good news, you know these rules. It has to begin with a letter. It can only contain letters, numbers, and underscores. No punctuation, no spaces. It can't be a reserved word, like application. Make it more relevant. We already talked about that. Have it describe what it's storing, and then follow a few standards. So first of all, these are the rules. You break the rules, it won't work. The standards are, it's good style to do a uppercase, lowercase, camel casing style so that it is sort of a good style for programmers. If you break the style, it might still work, but you'll lose a mark because I want you to have good coding style. Good news, like I said, you've already done this. Okay, here's an example. The data type, int, programmers are lazy, so they didn't want to write the whole word integer, so they just shortened it to int. Number, that's the name of it, equals 0, semicolon. Semicolon, remember, ends the line of code. From this point forward in your code, you have a variable called number that you can do whatever you want with it. Okay? So notice how the type is put first, then the name, then equals 0. By the way, the equals 0 part is actually optional. You could have just put the semicolon right there. I would never, ever, ever, ever recommend that though. Okay? Not because C# would do something bad with it, but it's, again, bad style. Okay? And there's more in-depth reasoning behind that, but I'll move on from that. Okay, so now I got it. Big deal. What do I do with the variable? Well, obviously you want to change it. That's why it's called a variable, right? Now, in math class and in science class, variables are used very lightly, okay, in the sense that there isn't a lot of rules for how you use them. So, for example, in math class, I can do this. I can go x equals 5, but I can also do this. And they essentially mean the same thing, right? Not so in computer science. Computer science is more specific. In computer, and maybe your teachers have done this. Have they ever done this idea with the left-hand side and the right-hand side? Anyone ever seen this in math? And they'll say x equals 5. So in computer science, it's always the case that the variable goes on the left-hand side, and the thing going into the variable goes on the right-hand side. So always think of it as going this direction. So this would not make sense, because what it's saying is x is getting put into 5? What? No. But this one makes sense. A 5 is being put into x. That makes sense. This one is right. This one is wrong. Okay? So you got to remember that. Because your math and science teachers have always been loose about the way that works. Computer science, more specific. Always follows this format. So the computer doesn't get confused. Because to the computer now, this makes sense. This makes no sense. Okay? It's something that I bet you someone in here will probably do just because you've been trained that way. Okay? All right, so that's what it says right here. Always on the left-hand side, and what's going in is always on the right. Okay. So then you can do math with it. And you guys know your math, right? So you know what these things are. That's multiplication. You probably don't do that in math class, but you knew that on the computer you had to type the star. That's the division. You knew that, I hope. That's addition and subtraction. I hope you knew those ones, right? Those are your basic 4 math operations. But now let me add another one in there. The addition sign can also mean concatenate. Does anyone remember what that word meant? No. Concatenate is it's just me trying to sound smart, but it essentially just means to join. Don't add them, just join them. When would I be joining stuff? Well, let's think for a sec. Let's say that I had this. Is that a number? What math would you do with that? There's a math operator, the addition sign. Go ahead, give me the answer to that. What's the answer to that? Cat is 5, yeah. Why? Because it's not actually adding anything here, right? Now, what if I did this? Oh. When it sees this, and let me do this maybe even. This it knows how to add, right? It go, oh, I got you, 8. But now you want me to add that to is? 8 plus is? I can't do that. So what it does is it concatenates. And the word concatenate just means to join. So it joins the word cat with the word is. It joins them, and then it joins the 8 together. So now we have that. Well, I drew them. But that's actually a good point. If you didn't, it doesn't. It doesn't assume you need spaces. So what if I did this? And I'll write it real. What's the answer? Cat dog. Cat dog, right. No space. If you want a space, you got to put in a space. So that's what that means, concatenate. Okay, moving on. Oh, and I explain it. To join together. So concatenate is used with strings to join them. Because we don't do math with strings. We just join them. Okay. And you knew this. There's an order, sometimes called the order of operations to this. Again, I'm not going to go over this quickly because you guys know this. This is done before this. But then that concatenation is actually done last, as we just saw in that example. Okay? So let's see how good you guys are. You know you can do brackets. How old is this adult? Think, don't say think. Just think. Think. Without the answer. How old is this adult? And let's see if you were right. If you're right, you're going to give me an air high five when I reveal the answer. Okay? So first of all, order of operations. Brackets are always done first. So we get this. Okay? Then order of operations. Multiplication is always done before subtraction. So then we have this. And 30 minus 9 is 21. High five for those who got it. Excellent work. I now have renewed energy that your math teachers actually did their jobs. Good. All right. Now, if they're the same precedence, they're evaluated left to right. And I think you knew that as well from math class. So how old is this adult? Think it. Think it. Don't say it. They're all additions and subtractions. They're all of the same order. Left to right. So 2 plus 3, 5, minus 4, 1, plus 5, 6, minus 1 is, air high five for those who got 5. Again, my enthusiasm is renewed that your math teachers did their work. Hey! You guys know who that is? That's the Fonz, yeah. because it's cool. All right, so here's what I need you guys to do right now. I need you to build this quick design for me. So let's fire up your monitors. Open up a C# project, call it variable example 1, because we'll be doing 2 of them, not both today, but 2 over the units. Save a project called variable example 1 and build this very simple design. This simple design will have a text box called txt input, and name them this as well, a button named btn enter, and a label called LBL output. I don't care how pretty it is. You can make it pretty if you want, but I don't need you to worry about that. It's just an example. This is more about the code than the design. If you want your label to look like mine, you can set that thing called auto size to false, but you don't have to. You can just throw a label on there, okay? So let's quickly do this in the next couple minutes. I'll get this example up and running while I pause the video. Okay, so here's mine. And again, I made just the fonts bigger so it's easier to see. TXT input, LBL output, and a button just called enter. This is computer basics right now, right? So I think I may have said this earlier in the year, that a computer at its very basic level is input, process, output. I'll even use good old flowchart symbols to remind you guys. This is the input symbol and the output symbol. And process is just a rectangle. And we'll use a little arrow to represent that that's what happens, right? You put an input, it does something with it, and it gives you output. But now, in the middle area here, we're going to add a component to processing. And obviously, you knew probably that this was happening inside the computer. But inside the computer, it is storing something. It is remembering something. So there's an element of storage happening here. And that storage is essentially where the variables come in. We need it to remember something in the processing stage. It will remember something so that it can give you good output. So that's real basic. So that's exactly what we're going to do as we code this thing. Okay, so let's do that. Jump to C#, and the only thing we're going to code is the enter button. So I'm going to clear space here, so I got a nice big code window for you guys. So I'm going to adjust the IDE. And here you can see that we have a flashing cursor after we double click the enter button. And if we get lost, we can see that this says button enter. When I click it, what should I do? Well, exactly, that's what's happening. Okay, so when I click the enter button, what should I do? All right, so here's what we're going to do. Just leaving a little bit of space. You don't have to. I'm just leaving it so it's easier for you guys to see. So what we're going to do is we're going to make a variable. It's going to be a string. Hey, it's blue. Who remembers what blue means? It's what's called a reserved word. In other words, I couldn't call my string string. I couldn't call string string because that's a reserved word. So I'm going to hold a value. So I'm going to call it value equals number equals. Okay? So there it is. Now, you might be wondering, what's this green line all about there, C#? Why are you doing that to me? This is green. A green underline is kind of a warning. It's not a problem at this point. It's basically saying, hey, you just made a variable, but you didn't do anything with it. Are you sure you want this? Don't worry, C#. Relax. I'm going to get to that, right? But this is the process again, right? The process of making a variable is, this is the data type. So it will be storing characters. This is the name I'm giving it. So just like when I name my objects on my design, I take ownership of this thing by saying, I'm going to call, it's like my baby. My baby is going to be called value. Then an equal sign. Get that. And then on this side is the value I'm putting in it. So it will become, this will be that. And then the semicolon at the end just finishes the line. Okay? And what's happening is, behind the scenes, in the computer's memory, so if this is all the memory inside a computer, a chunk of it has just been taken, and it's being called value. And in there is the words number with an equal sign. Like, that's being put in there. That's what's happening behind the scenes by your code running that line. as soon as it runs. It hasn't run yet. But let's keep going. Let's make another one. String text equals, okay? So it starts the same way. I have the data type, string. I have the name for it, text. So now, sitting inside the computer's memory is now two things, right? So inside the computer's memory is something called value, and it has something in there. Number equals. And then it made something called text, but it's empty right now. There's nothing in there because we haven't put anything here right now. Now here's where it gets a little weird, okay? What we're going to do now is we're going to do this. We're going to put txt input. Well, that's our text box. Dot text, semicolon. Okay? Now, I'm just going to separate these. You don't need to do that in your code, but now what I'm saying is, oh, okay, what text, where is this? You get this from the user. Whatever, it looks out here and goes, this thing here, that thing, whoops, that thing there called the text box, pull out the text of it. So what you may want to do with lines like this, because it may be hard for you to understand what's going on that line of code, is read it backwards. Sometimes that's helpful. Hang on, let me just get rid of this. Because if you read it backwards, it says, take the text from that text box. And you know it's your text box because you named it. Take the text from that text box and put it into this. What's this? It's a stored memory location that holds a string. So whatever I type in that text box will be stored inside that string. Okay, I hope that makes sense mostly. Okay, let's make another one. Int number1 equals. Okay, so now we're going to make a number. This is not text. This is a value. And what I'm hoping is what they type in that text box is a number. The problem is a text box at the point you create a text box doesn't know what's going in there. There's no idea. It's obviously text. That's why it's called a text box. So what I put in the text box, I had to put into a string because it's text. But now I want to change it. I want to change it into a number. And the way you do that is with the keyword convert. Whoops. Notice it'll appear in a slightly different color. It's not really blue, it's gray. Because convert is even extra special meaning. And the thing about convert that makes it even more special is it actually starts with a capital C. It breaks the rule that we normally don't because convert is even more powerful. Did anyone know any other code that we've used that did that? We did do one. Application. Remember the word application.exit? Application started with a capital A. Anyways, don't worry about it. Convert dot to int 32 bracket text. Okay, so what? Okay, so here's what's going on here. This is code, obviously. This is not the easiest code to digest when you first see it because it's kind of cryptic, right? It's kind of hard to understand that. For some of you, that's why the example's here, is just take that and you know what, when you go and do your problem, just copy that code. Don't worry about understanding it in any great detail. Just go, yep, whatever it does, it does. It does its thing. I don't care. For others, again, maybe read it backwards. Say, okay, I take this text, I convert the text to an integer. What do you think the 32 means, by the way? 32. See how good you guys are? You even knew that. So it converted it to a 32-bit integer. It converted it to a 32-bit integer. And then it stored it in my integer called number1. And if I go even deeper, I can think a little bit more about that. And I can go, well, let's think all the way back to where the user was. So the user typed text in a text box. I took that text and stored it in there. Then what I stored there, I converted to an integer. And now I have it. What? But yeah, that's how you do it so that now I can take that thing and do whatever I want with it. So now it's actually something I can do math with. So let's do math with it. Let's take it and, well, let's not do any math with it. Let's put it out where the user can see it. So they can see it in this label right here. Oh, okay. So let's put it out there. What did I just do? So leave a space, and we're going to say LBL output, that's the label, dot text equals value plus number 1. Okay. So let me just pull these together. Whoops. And before you try and run this, you may want to run this, but let me just say, let me draw what would happen here, okay? I know we're almost out of time, so I'm going to go quick here. So here's the text box. The user just hit enter. Let's say the user typed a 10 in that text box, and then they hit the enter button. According to our code, I start by making, over here in memory, something called value, with a lowercase v, and I put in there number equals. It's a string. Then I make a second variable called text, also a string. And for that one, I take the text out of this text box, the characters 1 and 0, characters, not number, and I store them. But then I say, now make me something called number 1. And this isn't text. This is a number. What I do is I convert this into that number, so now this is an actual number. Got it. Now, in the last instruction, I say, oh, by the way, you've got this thing out here, this label that's out there. Into the text of that label, because remember, we always go this way, take value, which is text, and number, and add them? How do I add text and a number? I can't. I have to join them, which was the fancy word for that? Concatenate. It's crazy, I know. It's tricky, but I wanted to go slow to show you the world's crappiest program, but here it is. Oops. One sec. That's my fault for double-clicking something I shouldn't have. Let me try it again. I'm typing 10, and get ready, 10. Wow, that's so exciting. It's so exciting, but it works, okay? Now, I could have done other things. I could have done math with it and other things, of which we'll do a little bit of tomorrow because we're almost out of time, and I'll explain that code in more detail tomorrow as we lay it out. So let's continue. These were the 4 lines we had yesterday, and if I just run these, just so you can see, it does the most exciting thing. I type a number in there and hit enter, and then the number reappears down here. Ooh. Okay, so a couple other things we're going to do now. Okay. We're going to slip a line of code in between the second last and last line that we had there. So we're going to put a line of code in there. I'll leave a little extra space so you can see where it's going. And we're going to do this. Long number 2, because we already have something called number 1, equals long of number 1. And in a second, I'm going to explain what that line does. Okay? But this is what the line looks like. You'll notice the strange brackets. This line of code, I will probably say that you will probably not need for the most part. Okay? For most of the course, you will not need a line of code like this, but some of you might, depending on the way you solve problems, or for something like your final project. This might be something you need. Plus, any of you that might be taking, say, the grade 11 course, it's a little peek ahead at some of the sort of stuff you do in other sort of programming courses. Then the next line will be very similar. It'll say float number 3 equals float number 2. Okay. And then finally, double number 4 equals double number 3. And then the only other change I want you to make is at the very end of the line that we did yesterday, instead of displaying number 1, I want you to switch it to number 4. Okay? So I'll just remove all the extra spaces now. So this should be what your code would look like. Okay? What we just added just now was, whoops, let's Let's not happen. Let's just use the smartboard instead of trying to do it fancy. We just added these 3 lines right here. Those are the 3 lines that we just added. Okay. So insert these 3 lines. They have a weird syntax to them, a weird way they're written. So now I'm going to, and that's it. This is going to be the end of the example. So once you've got that code in there, run it. Oh, and the one other change we made is this should now be a 4 right there. And I want to kind of explain what's going on in these 4 lines. The 3 we just inserted, by the way, will not most likely be stuff you'll need to use. However, the first couple, especially the first 2 or the second 2 lines, string text equals txt input, int number 1, definitely going to need those lines. And you'll definitely most likely need a line like the last line. Okay? So before I get into the specifics of these lines, in reality what's happening is we'll skip over the first line. This is just an example of a basic variable. But in this one, the second line, we create a variable. Okay, and as we know, a variable is a piece of memory. So we created a piece of memory using a line that creates it or declares it, declares the variable. But we got its input from our user. And really, it's the user interface where we got it from, right? It was the text box out on the user interface is where we got that input, and we stored it in a variable called text. That's going to be a super important line of code like that for most of the programs you're going to write for this unit, because you're going to need the user input to do something with it. Question?
How do you go about getting the view back on the page back?
Okay, so if you're not seeing your thing, over on the project window you should see something that says Form 1, and you want to double click that. Okay, hang on, so I'll be right there. The whole project? Let me see. Okay, here. Let's see. Yeah. There you go. Okay, so that line right there that I'm pointing to will definitely be one that you will have to use again. Now, the name of the variable might change. You might call it something else. And the name of your text box might change to something else. But a line like that you will definitely be needing again. Okay? Similarly, on the bottom here, this kind of a line of code is going to be needed again. This is where you take a user interface. This way you're going the other way. In the first one, we were getting input from the user interface. In this bottom line, we're putting something out onto the user interface. So we're taking some sort of calculation and displaying it out on a label. Now, this is a text box. This is a label. But it's the same kind of thing. There are 2 different things out on the GUI, on the user interface. This could have been both labels, right, in a sense. But you can't get input from a label, right? You can't actually type into it. These could have both been text boxes. But maybe we don't want this bottom one to be something that the user can type in. So the label works better for that, right? So it depends on the sort of program you're writing. So you'll definitely need a line of code like that bottom one again. And then finally, this line right here, which is, again, a bit of a weird one, is definitely something as well that you will have to do for problem solving in this unit. It's a weird thing, but the reality is when you get input from the user's text box, that's why it's called a text box. It comes in as text. It doesn't come in as a number. We have to convert it to a number so that we can use it. And this is, again, that assumption that we make as humans because we say, oh, well, if they type a number in a text box, it's a number. No, the computer assumes it's text. You have to do the conversion. So again, those 3 lines, this one, and this bottom one, not in that format, but those 3 lines you will definitely be using again in some other format. The other ones, they're kind of just bonus on there, a little bit bonus of what's going on. So all of this, oh, and I guess I should make sure it works. It's not that exciting, as always. I type a number in there, and it comes out there. Okay, so we see really nothing that different. Okay, so this is all in the notes. Okay, all the code's there as well. Does the same thing ours does. But now I want to kind of go through the specifics of these lines. Okay? I also want you to know that this is in the notes. So if you ever want to review these lines of code, they are in the notes. So this first line, string value equals number. This is just creating a variable. A variable called value of type string, and its initial value is those words right there. Okay? It's that same thing we talked about yesterday, how to create a variable. So that's all that first line was an example of that. This second line is also creating a variable, but in this one, you're getting the input from a text box object, which is out on your user interface. So that's a little bit more sort of interesting how that works. You also are using the dot text here because that's the part of the text box you're reading. If you didn't put that, if you just put, the computer would be confused. Well, what about the text box do you want? Well, I want the text out of the text box. Okay? So that's what it's trying to explain to you here. And then in this line, I'm doing a conversion. And here I had to use a little special keyword, converts, to turn the text into an integer. Okay? Again, this probably to me this is the most confusing line out of all the ones we typed because it's so cryptic, it's so coded. But if you sort of stop for a second and think about it, you can kind of get a feel for how it works. Okay? Notices here in the text, in the notes as well, you can convert to a double. That would be something you're probably going to need to do for one of the assignments. So in addition to converting to integers, you can also do converting to doubles. But again, I'm here for helping for that sort of stuff. Okay. Then the three lines I did after that had this weird syntax where it put something in brackets. Okay? This is called casting a variable. The analogy I'd give is if you ever took drama, right, and all of a sudden you're playing a doctor in a drama production, you're not really a doctor, you're just playing a doctor. They call that casting in acting class, right? So when you cast a variable, what I'm saying is number 1 here was an integer. What I'm doing is I'm taking number 1 and turning it into a long temporarily. It's not really a long. It's not a long, it just plays one on TV, right? It's just being turned temporarily into a long so that I can store it in this variable called number 2. Again, for most of you, this is not going to apply. This is nothing you need to worry about. This is kind of a level of sort of complexity that you don't need to worry about in too much detail. Okay? And then I do it again, so it's the same basic idea. There's some more notes in the folder. You can read about that, about sort of this idea of maybe there's a loss of precision in some of this. And then in the final line, we reverse the process, so now we're taking some value and putting it out into the label. So we're going the other direction this time. Now here, we're taking value, which is a string, and number 4, which is a double, and combining them. Now it doesn't do math with a string. It joins those words joined with that number, and then it's put into the text of the label. Okay? Whew. So that's the detailed description of that. Okay? And that's the basics of variables. All right.